Let's practice evaluating trig functions of special angles together. And since we are dealing with special angles, keep in mind that we are not going to be using a calculator, because if they are special, then we should be able to do them by hand, or that's going to be the goal that we're going to practice to get better at. Keep in mind that for each of these practice problems, the angles are sometimes measured in degrees and sometimes they are measured in radians. For number 1, we have secant of 135 degrees. Now the first thing I'd like to do is just figure out where 135 degrees is. So notice we have the positive x-axis, that's going to be where 0 degrees is over here to the right, and then we have 90 degrees up here on the positive y-axis, and this would be 180 degrees over here to the negative x-axis. So where is that 135 degrees going to line up? Now 135 degrees happens to be exactly 45 degrees between 90 and 180, so we're really looking at an angle that looks like this. So this would be our angle measure that we're talking about. This right here would be our 135, okay? And so once we identify where 135 is, then we can go ahead and draw a reference angle or look at our triangle here, right? So now that we know where 135 degrees is, we can go ahead and create our reference angle or our triangle that we can actually use to figure out what secant of 135 is. So not the most perfect triangle here, but this would be our 45-degree reference angle, and this is a right triangle, so this is a 45, 45, 90 triangle. Now, in case you forgot, there are these two special triangles, our 45, 45, 90 and 30, 60, 90 that we can reference here. And so if we go ahead and know that we are in quadrant 2, then we should have some values here. So in quadrant 2, we have negative x value. So we should have a -1 for our x value here. We should have a +1 for our y value, because in quadrant 2, we have negative comma positive. And then our hypotenuse that we're going to have for this triangle is going to be the square root of 2. Okay, so let's go ahead and see if we can use these different measures to figure out what secant of 135 is. Now, if we keep in mind that secant is the reciprocal to cosine, right? So if we have secant of some angle measure, that's equal to just 1 over cosine of that same angle measure. So if we can figure out what cosine of this 45 degrees is in this quadrant, then we can figure out what secant is. So let's figure out first what cosine of 45 is in quadrant 2. So cosine of this 45 degrees in this quadrant, that's going to be cosine is what? That's going to be adjacent over hypotenuse. Now the adjacent side is going to be -1 over positive root 2. So we can go ahead and write that's going to be -1 over a positive root 2. And now if that's what cosine of 45 degrees is, then remember we're going to have 1 over that, or the reciprocal. So we just have to make sure we flip this upside down, right? So that if we're finding secant, then we find the reciprocal of this. So that means in this quadrant, if we're going to go ahead and find secant of this 45 degrees, again, this is just in this quadrant, that's going to be the reciprocal. So flipping it upside down, that's going to be a root 2 over a -1. And that's going to just simplify down into just being -√2. Okay, so in conclusion, if we wanted to find secant of 135 degrees, that is going to equal -√2. Okay, so we were just going ahead and using our reference triangles to help us find what secant of 135 was. 45 degrees was our reference angle to help us do that. All right, let's check out number 2. For number 2, we have tangent of 240 degrees. All right, so let's figure out where 240 degrees is. So we have 0, we have 90, 180s on the negative x-axis, and then this is 270 on the negative y-axis. So 240 is only 30 away from 270, so it's got to be closer to 270, so maybe something like this. So if we were going ahead and just looking where this 240 degrees is, that's really coming from here and then swinging all the way around. So this would be the 240 degrees. Okay. Now, if we take a look and try to make a reference angle or triangle, again, that's got to be in respect to the x-axis. And so if we go ahead and draw a triangle, it's got to be a right triangle, so something like this, right? Then we can go ahead and say, okay, we know that this is a right triangle, and then this is going to be a 60 degrees reference angle. So that's 60, and this would be 30. Okay, so here we have a 30, 60, 90 triangle. For reference here, we're going to go ahead and use the ratios of 1 to 2 to root 3 here. So if we're in quadrant 3, we have to have negative negative for the x and y value. So this will be actually a -1. This would be a negative root 3, right? Because we're going down in this quadrant, and then we should have a positive 2. The hypotenuse is always positive, okay? So if we're going to go ahead and see if we can find tangent of this 60-degree angle measure here. So if we go ahead and write tangent of this 60 degrees. Again, 60 degrees is just going to help us find out what tangent of 240 is, okay? So tangent of 60 degrees, that's going to be what? Opposite over adjacent, or y over x. So here is going to be opposite over adjacent, so it's going to be this negative root 3 on top of a -1. And then if we go ahead and say, what is this negative root 3 over -1, that's just going to equal positive root 3, right? Because a negative divided by a negative is a positive. And so we can go ahead and say that tangent of 240 degrees is going to be a positive root 3. And it makes sense this answer is positive just because tangent ratios are always going to be positive in quadrant 3, because negative over negative is always positive. Here's number 3. For number 3, we have sine of -150 degrees. So in this case, keep in mind that we have a negative angle measure, so let's go the reverse way. So we have 0 degrees here. We can go -90, which is the same thing as positive 270, but hopefully this helps us figure out where this -150 is. So we're just going clockwise this time, right? Now, -150 is only 30 degrees away from -180, so maybe something like that. And then this right here would be where 0 is. So this angle measure from here to here would be the -150 degrees that we are talking about, okay? And you can see if we create a right triangle, this would be a 30-degree reference angle here, right? Just because 150 is 30 away from 180. And so we should end up with a 30, 60, 90 triangle. Okay, so we're in quadrant 3 here, so we're going to have a -x and a -y, so we're going to have negative root 3, and then we have -1, and then we have a positive 2 for the hypotenuse, since that's always positive. Okay, so if we find sine of 30 degrees, that's going to help us find out sine of -150. Now, sine of 30, sine is what? Opposite over hypotenuse, or y over r. So here's the opposite and here's the hypotenuse, or the y value and the radius, or the r value. So that is going to end up being -1 over a positive 2. And that simplifies down into just being -1/2. So sine of -150 should equal -1/2. Here's number 4. For number 4, we have cosecant of -420 degrees. Now, if I were you, if you have any angle measures that are further than 360 away from 0, 360 degrees that is, I would just go ahead and add 360 or take away 360 just so you can deal with some smaller angles. You're going to end up in the same location just because you're making a full circle. So this equivalent would just be taking cosecant of negative, what is that going to be, 60 degrees? Okay, so whenever you have an angle measure that's so big, just go ahead and add 360 as many times as you need to get a smaller angle here, or an angle that's a little bit easier to work with. All right, so where's -60 degrees? Well, 0 degrees is on the positive x-axis, -90 degrees is down here in a negative y-axis. So -60 should be closer to -90 than it is to 0. So I'm going to go ahead and draw maybe something like this. This looks like it could be -60 roughly, okay? And so that angle measure really from here to here, this is really, this angle measure is -60 between these two yellow lines. I'm not gonna go ahead and draw where the 60 is, it's gonna get a little messy here. So I'm just gonna go ahead and connect this to make our reference angle, or triangle rather. Okay, same idea. So this blue triangle represents our right triangle, 60 degrees is our reference angle, and this ends up being a 30, 60, 90 triangle that we are dealing with, okay? And so let's see what our ratios are gonna be. So in quadrant 4, our x values are always positive, so it's a positive 1. Our y values are always negative, it's negative root 3, and our hypotenuse is always positive, so it's a positive 2. We're looking for what cosecant is, but that's the reciprocal of sine, right? So maybe let's start with sine of 60 degrees, and that can help us out here. So if we take sine of 60 degrees, let's go ahead and see what that's going to be. So sine is what? Opposite over hypotenuse, also known as y over r. So here's the opposite, and then here's the hypotenuse. So that's going to be negative root 3 over 2, right? That's what sine of that 60 would be. And so if we wanted to go ahead and find what the cosecant of that 60 degrees would be, that's going to be the reciprocal, right? So we know sine and cosecant hopefully are reciprocal functions. So if we go ahead and find what cosecant of this 60 degrees, again, the 60 is really just helping us with the negative 420, then this would be equal to the positive 2 on top of the negative root 3. Okay, now we're going to go ahead and just make sure that we rationalize this denominator here. So let's go ahead and multiply this by root 3 over root 3. If we go ahead and do so, then we're going to get 2 times root 3 on top, and then we're going to get, what is that? Root 3 times root 3 is just a 3, and we have a negative, so we can put that in the middle here. So we can go ahead and say that our ratio here is going to be a negative 2 root 3 over 3. That would be our ratio here. Here's number 5. For number 5, we have cosine of 7 pi over 4. All right, so you got to practice working with some radians here, so hopefully this gets a little bit more comfortable. Feel free to convert these into degrees if you need to, but 0 radians is there. We have pi over 2, that's 90 degrees. Pi is the same thing as 180, and then it looks like we're going to have 3 pi over 2, that's 270 degrees, and then this would be equal to 2 pi, which is back to 360 degrees, right? Now, the 7 pi over 4 isn't quite 8 pi over 4. 8 pi over 4 would be 2 whole pi's, right? So it looks like we are a quarter away. Now, if it helps you just kind of get common denominators here, if we multiply top and bottom by 2, this is really 6 pi over 4, right? And if you really think about this one, if you want common denominators, this is really 8 pi over 4. So what's exactly between 6 pi over 4 and 8 pi over 4 would be 7 pi over 4, which is what we have. And so the 7 pi over 4 that we're given must be directly in the middle between these two angle measures. So here we had 0 where we started, and then this 7 pi over 4 really was this really big angle coming around the side here. That's 7 pi over 4. I can label that just because it won't get in the way of our reference triangle. And we know this is a 45-degree angle, hopefully, okay, because it's halfway between the 90. So this triangle here would be 45, 45, 90. I'll just put 145 in here, so hopefully that you get the picture of what's going on. Now, in terms of our ratios, we're going to use the 45, 45, 90. And so this is going to be a positive 1 in quadrant 4. This is going to be a negative 1 in quadrant 4 and a positive root 2. Okay. So if we go ahead and find cosine of 45, or I'll practice using radians here, so hopefully you get a little bit more familiar. So that's the same thing as 45 degrees. That's going to be cosine is what? Adjacent over hypotenuse. That's going to be 1 over root 2, or also it's known as x over r. That's going to be 1 over root 2 also. So we're going to go ahead and write this is positive 1 over this positive root 2. Okay, and so if we go ahead and write it like that, that's fine, but we're also going to go ahead and rationalize this thing. So let's go ahead and multiply this by root 2 over root 2. And if we do that, we're going to get root 2 over 2. All right, that would be our ratio. So we can go ahead and say cosine of 7 pi over 4 is going to be this positive root 2 over 2. Alrighty, here's number 6. For number 6, we have cotangent of negative 8 pi over 3. Negative 8 pi over 3, let's see. To me, that seems like it's a pretty big angle, or it's an angle that's pretty far away from 0. So I think it's past 360, right? So let's see here. If we go ahead and add 2 pi to this. Remember, we did this earlier in problem 4, I think, yeah. This negative 420 was pretty far away, so we added 360 to make it a little, more manageable. And so this over here is pretty far away from 0 as well. So if we add 2 pi, that's the same thing as 360 degrees. It'll get us to the same location, right? Now, what is 2 pi in terms of common denominators with the 3? Well, 2 pi is the same thing as 6 pi over 3. Right? 6 pi over 3 is the same thing as 2 pi. So if we're at negative 8 pi over 3 and we add 6 pi over 3, our equivalent here really is finding cotangent of this negative 2 pi over 3. Right? And now 2 pi over 3, if you know 1 pi over 3 is 60 degrees, then negative 2 pi over 3 is negative 120, and that's just a little bit more manageable, hopefully, to help you imagine what's going on. So just, another way to think about it in case that helps. All right, so where's negative 2 pi over 3? Well, 0 radians is here. Negative pi over 2 radians is here. Negative pi is going to be negative 180 degrees. All right, so if we're trying to just conceptualize a little bit, let's try to get some common denominators. We have thirds here, we have halves here, and wholes here. So the least common denominator is going to be 6. So this is the same thing as negative 3 pi over 6, right? That's the same thing as half. And then over here, for this negative pi, this is the same thing as negative 6 pi over 6, right? Because 6 over 6 is just going to be 1. So if we think about where this, this negative 2 pi over 3 is, that equivalent, I'm just going to write it on the side here, that's going to be negative 4 pi over 6, right? The same thing, 2/3 and 4/6. So where is 4/6 going to be? That's going to be a little closer to 3/6, right? So 4/6 is closer to 3/6, so this is where I think it's going to be. And hopefully that makes sense because I kind of mentioned earlier that this would be 120 degrees. So if you want to just convert the radians to degrees, that's fine too. But this is going to be the negative 8 pi over 3 that we were beginning with here, okay? Now, I think we have enough information to draw a triangle, so this reference angle here is going to be 60 degrees, or pi over 3. So we have a 30, 60, 90 triangle. All right, so we're in quadrant 3, so we should have negative x, negative y. So this should be a negative 1, a negative root 3, and then a positive 2 for the hypotenuse. Now we want to find cotangent, but the reciprocal is tangent, so that's usually easier to kind of start with here. So tangent of 60, or I'll try to practice using radians here, that's pi over 3, same thing as 60 degrees. Tangent is what? It's opposite over adjacent, or y over x. So opposite over adjacent, or y over x, that's going to be negative root 3 over negative 1. And that's going to be, well, that simplifies down to what? It's just going to be positive root 3 over positive 1. And I'm keeping it as a fraction real quick just because we have to go ahead and reciprocate this, right? Or flip it upside down. So if we find cotangent of this pi over 3, that's just going to be it upside down. So that's going to be this 1 over root 3, which it's a little bit more work for us. We just have to make sure we rationalize the denominator here, multiply by root 3 over root 3. And if we do that, we're just going to get this root 3 over 3. All right, so our ratio here is going to be positive root 3 over 3. That will be our answer. All right, here is number 7. We have tangent of negative 3 pi over 4. All right, so here is 0 radians. And then this would be negative pi over 2 radians, or negative 90 degrees. And then this would be negative pi, which is negative 180 degrees. Okay, so where does negative 3 pi over 4 fit? Well, this is going to be the same thing as negative 2 pi over 4, if you want to think about it, using the same denominators. And then this negative pi is the same thing as negative 4 pi over 4. So what's between negative 2 over 4 and negative 4 over 4? That's going to be negative 3 over 4. So it's exactly in the middle here between. So we know we're dealing with a 45-degree angle, or a pi over 4, which is the same thing. Okay, so this right here we can see is our angle. This is where the negative 3 pi over 4, that's what that looks like. And then we can create a 45, 45, 90 triangle using the reference angle of 45 degrees, or pi over 4, and that's how far it is from the x-axis. Okay, so we're in quadrant 3. We're dealing with a 45, 45, 90, so negative x, negative y, and then a positive root 2, okay, because quadrant 3 is negative, negative. We're finding tangent here, so tangent of 45 degrees, that's got to be what? Opposite over adjacent, so here's opposite, here's adjacent, or it's the ratio of y to x, so rise to run here. So if we go ahead and take tangent, and I'll use radians as well here, of pi over 4, because that's going to be 45 degrees, that's going to be the -1 over -1. And -1 over -1 is equal to +1. So this ratio is just going to be a 1-to-1 ratio, or just 1. All right, here is one final practice problem for number 8. We have secant of 11 pi over 6. Alrighty, so where's 11 pi over 6? We have 0 radians, and then we have pi over 2, that's 90 degrees. Pi, that's 180, 3 pi over 2, that's 270, and then this is going to be 2 whole pi's again. And now, since we're dealing with sixths here, I think it's helpful to know that 11 pi over 6 is really close to 12 pi over 6, right? 12 pi over 6 is the same thing as 2 whole pi's, or a full circle here, so we're really only 1/6 away from here, right? So if we start measuring our 11 pi over 6 from our positive x-axis, we should end up really close to our full circle here, but it's really going to be this outer side here because it's almost a full circle. That's the 11 pi over 6, okay? And when we do that, 11 pi over 6, if you weren't sure, that is the same thing as 30 degrees. So we're going to end up with a 30, 60, 90 triangle. And so we're going to end up with a triangle here with this pi over 6 reference angle. And if you weren't sure, pi over 6 is 30 degrees. So this angle in here, really running out of space here, is going to be 30 degrees, or pi over 6, however you want to think about that, okay? All right, so since this is a 30, 60, 90, we're in quadrant 4. This is going to be positive x value, so it's a positive root 3, but a negative y value, so -1. And then we have a positive 2 here, okay? So let's go ahead. If we want secant, the reciprocal of secant is cosine, right? So let's do cosine first. Cosine of this pi over 6, that's our reference angle. That should help us out here. So cosine of pi over 6 is going to be adjacent over hypotenuse, or our x over r, so that's going to be x and that's going to be r. So we're really looking here at root 3 over 2. Let's go ahead and write that down, root 3 over 2. But again, we're not looking for cosine, right? We're looking for secant, which is its reciprocal. So let's go ahead and make sure we flip this upside down, because if we find secant of pi over 6, that should help us with this 11 pi over 6. So secant of this pi over 6, that's going to get us this 2 on top instead, and then a root 3 on bottom. And then let's just go ahead and rationalize this. So multiply top and bottom by root 3, and so we should get this 2 root 3 over 3. Okay, so our final ratio here for secant of 11 pi over 6 is going to be this 2 times root 3, or 2 root 3 over 3. That would be our final ratio for secant of 11 pi over 6. So there you have 8 different practice problems on evaluating some exact specific angles using some trigonometry. If you found the video helpful, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.